Hi guys, I'm gonna be starting a new series. I'm gonna pick a random topic in science or maths, just talk about it. I'll try every week. Yeah, let's see how this goes. Today, as my first topic, I've chosen eddy currents. If you find this informative, I'm not forcing you. Subscribe if you want, I guess. Okay, let's start. So basically, eddy currents, right? I don't think you can see it. My camera quality is not that good. But the loops of electrical currents induced within conductors by a changing magnetic field. Now, this is some crazy vocab, right? Basically, loops of electric currents, right? So the electrons, they just swirl around like that, like in a circle, like within conductors. So like we know that conducting is a characteristic property of metals. So yeah, metals by a changing magnetic field. So you can move a magnet and yeah, an eddy current is generated. It was discovered in the 19th century and is still crucial in the topic of electromagnetism. So basically, it's when varying magnetic field, like when there's a varying magnetic field, electrons inside the material, they begin to swirl, right? And then like these swirl in a circular path, and that's called eddy current, right? They're called eddies because they move in the same manner as eddies with an IE in water. And eddy currents were actually discovered by this French physicist Léon Foucault in 1855. I apologize if I didn't spell that correctly, but that's E with an accent mark. And he demonstrated this by spinning a copper disc in magnetic field and showing how it slowed down because of the induced currents. And this experiment confirmed the existence of eddy currents and also showed that it opposes motion. This has few practical applications, like over here on the side I've written. So, like you might be shocked to know that we use eddy currents quite a lot in our daily lives. We use them in induction cooktops and then amusement park breaks. Alright, so eddy currents are really good at producing heat and resisting motion. So we use them in amusement park breaks and in recycling units to separate cans from glass or cans from paper waste. Where was I? Okay, yeah. So when you change a magnetic field, the E minus, that is electrons, move in loops, and the strength of the movement depends on the field charge. Either the magnetic field itself can be moving during an electric current. That is the example of dropping a magnet through a copper pipe, and you can see that the magnet slows down against gravity, or the conductor is moving through the magnetic field. So in a recycling unit, there'd be a treadmill. Sorry, no, I don't know what the correct word is. Treadmill? Okay, yeah, you can think of it as a treadmill, and like there'll be an eddy current somewhere, and when the metal passes through that, it gets sent up, right? And there's a level on top where all the cans are collected, and whatever does not react just goes down. It falls into a pit, and so that pit has paper waste, and the cans fly up. Like I think if I can try, I'll put a clip in there for you to see. But the cans are the conductors in this case, and they're moving through the electric field. So that's the second type. And the changing field is the reason the electrons move in a circular path, and these create localized currents. And the flow is circular and perpendicular to the direction of the magnetic field. And the strength also depends on properties of the conductor. Sometimes there's a good conductor, sometimes it's an okay-ish conductor, sometimes it's not even a conductor. So the amount of current produced also depends on conductors, obviously. Lenz's law, right? Lenz's law, it says that directions of induced current will oppose the change of magnetic field, so oppose the charge of the magnetic field or flux that created them. In short, eddy current acts as a way to resist motion and change what caused them in the first place. Now let me show you something. This example, I hope you can see it. Yeah, it is a pipe. It's a copper pipe with the green circle is a strong magnet, okay? And if you drop this strong magnet on this side, it falls normally because gravity does its job. But through the copper pipe, if you drop it, this fall is significantly slower through the pipe. I think I'll try putting a clip of that in too. Yeah, so that's that. And inside the tube, the eddy current opposes motion. That's eddy current in about 6 minutes for y'all. I hope you have a nice day. Bye.